Okay, so we're moving on to another bit of statistics. This is called standard deviation. It's a complicated formula. But for a lot of people in the exam, it is a lovely guaranteed 4 marks because you just learn the process and go with it. So standard deviation, it's similar to semi to quartile range. The value would come out at the end, tells us how spread out our numbers are. So standard deviation is a measure of spread that uses all the data in our sample. That means it doesn't just use the highest and lowest, it uses every single number on the list. And our answer is a score of how much all our values deviate or differ from the mean. Because the word deviation, if you deviate from the path, it means you go off the path. So the closer our answer is to 0, the less varied our... The closer our answer is to 0, the less varied our numbers. Now that goes for the other way as well. The bigger the number it is, the more varied it is. Okay, so the bigger the number means more varied. I'll just quickly add that in as well. Sorry, I'm still getting used to this pen. Okay, so the closer our answer is to 0, the less varied or more consistent our numbers in our sample are. So let's get straight into looking at the formula. So this is a formula here, and it is given to you in the exams, okay? A couple of new symbols for you all. This thing here means the sum of, or total. This one here, x with a line above it, is called x bar. That means our mean. And we all know what mean is. And then n stands for the number of numbers on our list. So this is our sample size. So if we have 7 numbers in our list, n minus 1 would be 6. So we'd put 6 in the bottom of the formula. The actual Greek letter for this is called sigma. It just looks like a capital M on its side or a funny looking capital E. So that is a formula, and as I've stressed up here, it is given to you in exams. You don't need to memorise it. There is another formula, but I'm not going to teach you that one purely because I have spoken to all the teachers and we are the consensus that we're only going to show you this one, okay? Right, let's have a look at some actual examples in action then. So, example 1. Adam scores the following results in his science test, and there are his percentages. We have to calculate his mean and standard deviation. So to do all of this, the first thing we do in a standard deviation question is we draw out this table. And this is a bit that takes all the kind of work in. So we're going to draw out this table here. Obviously, you would do it with rulers. And we put each of our numbers straight into the table. Now, I'm not putting the numbers in order, purely because I find people who try and put the numbers in order might miss one or accidentally change one of the numbers. So there is our table. What we're going to do now is if we add up all these numbers, this comes to 330. So our first thing to do is go get our mean. Now, our mean is the total of all the numbers divided by 5, because there's 5 numbers in the list, and that gives us 66. Sorry, that looks a bit like a 6. So our mean is 66. Now this column here, this one, the middle column, x is each of these numbers here, x bar is your mean. So what we do is we take this number here, 56, and we take away our mean, and that gives us minus 10. We then take the 60, take away our mean again, gives us minus 6. We then take the 80, take away 66 again, is 14, and so on. I'm not going to keep writing out all the numbers because in general I don't always have room for this. So 72 take away 66 is 6, and 62 take away 66 is minus 4. Now I'm going to let you into a wee secret here. If you add up all these numbers here, they actually add to 0. Okay, if they don't, something is going wrong, but it's not a huge deal. We don't have to always check that. Okay, this column here that I'm circling, that looks very like the middle column, but the difference is there's a squared on it. So all we actually do is square each of these numbers. Now please remember, all numbers squared turn positive. So minus 10 squared is 100, minus 6 squared is 36, 14 squared is 196, 6 squared is 36, 4 squared is 16. Now you are allowed a calculator for standard deviation, so please use it wisely. And our total gives us 384. Now this is the number we are really interested in. What this number here is, that is your sum, your total of the x minus x bar all squared. So I would say that in class, if I was talking, I would say that is the sum of your deviations squared. Now the formula for standard deviation was sigma x minus x bar all squared all over n minus 1. Now, the sum of this bit here, that is just the total of this column. So that 384 is your top number. On the bottom, n minus 1, we have 5 numbers in our list here. So 5 take away 1 is 4. Now, when you go work that out, you can just simply type in 384 divided by 4, hit your square root button, and it will give you 384 divided by 4 is the square root of 96. Which is 9.8. Now, I will stress that is actually to 1 decimal place. If they don't mention rounding, I would urge you to do 1 or 2 decimal places. Never do the nearest whole number. So that is our first example. It looks an awful lot when you glance back at it. We didn't really do anything too complicated. We did a bit of taking away and squaring. So part B follows on from this answer. And obviously this means absolutely nothing unless we've got another number to compare it to. So in part B, Adam's friend Brian does the same science tests, but he has a mean score of 70 and a standard deviation of 11.4. So I'm quickly just going to remind myself of the two results. So Adam had an average score of 66 and a standard deviation of, what was that last number, 9.8. Brian has a standard a mean of 70 and a standard deviation of 11.4. So we have to make two comparisons about Brian and Adam. First statement always talks about your mean. And I generally start with the second person. It's difficult, it's a horrendous question to mark as a teacher. The shorter the answer, the more concise it is, sometimes the better. So I'm going to start with Brian. And my first sentence starts with on average, because that is a different way of talking about the mean. So on average, Brian, now look at Brian, he gets an average score of 70 compared to 66. So on average, Brian scores, oh my goodness, look at that writing, scores higher than Adam. Okay, his results, second sentence is now going to talk about the standard deviation. So his results are, now his standard deviation is higher. Now the higher the number, the more spread out they are. So his results are more spread out. So his results are more varied. And you don't need to say why, but for the sake of your notes, I'm going to write this is due to a higher standard deviation. Now, we could have spun this question a completely different way. We could have talked about Adam and we would have said, on average, Adam scores lower than Brian. His results are less varied because Adam's numbers are closer together, so his would be less varied. Obviously, I'm only going to write down one, which is correct. Okay, let's look at a second example. So your mean. Oops. This time we're going to look at some sunflowers. So the height of some sunflowers are measured as the following centimetres. We have to calculate the mean and standard deviation. So I'm going to do my table again. And just putting the numbers into the table, not bothering to put them in order at all, so I don't make mistakes. And if I add up all that column, they come to 30. So step one is get your... So my mean is 30 divided by 6 numbers in this case, which is 5. So to the table, middle column, you do 3 take away 5 is minus 2. 5 take away 5 is 0. 2 take away 5 is minus 3. 9 take away 5 is 4. 1 take away 5 is minus 4. And 10 take away 5 is 5. I'm going to do a quick check that they all add up to 0. Yeah, it adds to 0. And standard deviation, square each of these numbers. Remember, they all turn positive. So minus 2 squared becomes 4. 0 squared is 0. 3 squared is 9. 4 squared is 16. 4 squared is 16. And 5 squared is 25. So remember, ignore those negatives when you are squaring them. And the total there gives us 70. Okay, remember this is the important number 2 is here. Okay, standard deviation, the formula is square root of sum of your deviations squared all over n minus 1. So that 70 goes on the top. N minus 1, we have 6 numbers this time. So we are going to put 5 on the bottom. And then 70 divided by 5 is 14. So we have the square root of 14, which is to 1 decimal place, 3.7 to 1 decimal place. Okay. Again, this means absolutely nothing until we go compare it to something. So let's have a look at part B. So after a week, the same sunflowers are measured again as the following centimetres. We have to write down the mean and standard deviation. Now I'm going to just, for my own sake, I'm going to write down the previous mean was 5 centimetres and the previous standard deviation was 3.7. Right, let's have a look at these numbers. 13, 15, 12, 19, 11 and 20. Our previous numbers were 3, 5, 2, 9, 1 and 10. Please have a look at both lists of numbers. What do you spot? Hopefully you'll see that the difference between the original numbers and the new numbers is that they've all grown by 10 centimetres. Very unlikely they all grow evenly, especially if I look at my sunflowers right now, but they have done for the sake of the example. Now, write down means there should be absolutely no working at all, and in a test this would only be worth 2 marks, and you're not going to do all that working again on the previous screen for just 2 marks. So it must be something quite simple. So I'm going to tell you a wee story. I've got a brother who's 2 years older than me. 10 years ago, he was still 2 years older than me. Next year, he will still be 2 years older than me. In 50 years' time, if we're lucky enough to still be alive, he will still be 2 years older than me. So as we grow or age, does the gap in our ages change at all? The answer is no. So as these flowers grow, have the gap between all my numbers in my list changed at all? There's still a difference of 2 between 3 and 5, and 13 and 15. There's still a difference of 3 between the 5 and the 2, and the 15 and 12. So they're not changing, they're not any more spread out if they've all grown the exact same. So the standard deviation is the exact same. Okay, and you don't have to say why, but for the sake of your notes, we'll say it's because there is no change in the spread. Okay. Now the mean, let's go back to that example of me and my brother. Our average age just now is 30 something. In 10 years' time, our average age will be 40 something. What's happening to our ages is we're both going up by 10. Same with the height of these flowers. So the average height will go up by 10. So the new standard deviation will be 15 centimetres. So the exercise I have set for you folks is a worksheet. Now it has none of these part B's on it. It is just as straightforward and it is just lots of the part A style questions. Again, there is bronze, silver and gold. Work your way through them. The answers are on the back. Let me know how you're getting on and if you're struggling at all. Hopefully this has been a good enough explanation, and if you're in class I would probably spend a good few periods on this because it is important. Later in the week I will upload another exercise which will focus on the sentence part, because that is the tricky bit, and it's hard because it's hard to get me to mark your sentences and things. And remember, I will always go with the latter part. Anyway, for this worksheet, as I say, you're just doing part A style. So good luck and take care.